Welcome back. Today we are tackling the chemistry concepts that students consistently find most confusing. Not just the definitions, but the reasoning behind them, so you can think through any question rather than just memorize an answer. Let us start. Number 1. Atomic structure. An atom has 3 types of particles. Protons in the nucleus, positively charged. Neutrons in the nucleus, no charge. Electrons orbiting outside the nucleus, negatively charged. The number of protons defines the element. Change the number of protons and you have a completely different element. That number is called the atomic number. The mass number is the total number of protons plus neutrons. Electrons are so light they contribute almost nothing to mass. Isotopes are atoms of the same element with different numbers of neutrons. Carbon-12 and carbon-14 are both carbon. Both have 6 protons. Carbon-12 has 6 neutrons. Carbon-14 has 8. The extra neutrons make carbon-14 unstable and radioactive, which is why we use it to date ancient objects. Number 2. Chemical bonding. Why do atoms bond at all? Because atoms want full outer electron shells. This is the octet rule. Most atoms are most stable when they have 8 electrons in their outermost shell. Atoms that are far from a full shell will either give away or take electrons, or share them, to reach that stable state. Ionic bonding, one atom gives electrons to another. Sodium has 1 electron in its outer shell. Chlorine needs 1 electron to fill its shell. Sodium gives its electron to chlorine. Both reach stability. The result is table salt, sodium chloride. The atoms are now oppositely charged ions that attract each other. Covalent bonding, atoms share electrons. Hydrogen needs 1 electron. Oxygen needs 2. 2 hydrogen atoms each share 1 electron with 1 oxygen atom. All 3 atoms reach stable shells. The result is water, HO. Metallic bonding, metal atoms give their outer electrons into a shared sea of electrons that flows freely. This is why metals conduct electricity and heat. The free electrons can carry charge and energy. Number 3. The periodic table. The periodic table is arranged by atomic number, not atomic mass, as many students assume. The rows are called periods. As you move across a period, you are adding 1 proton and 1 electron at a time. The columns are called groups. Elements in the same group have the same number of outer electrons, which is why they have similar chemical properties. All group 1 elements react violently with water. All group 7 elements are reactive nonmetals called halogens. All group 8 elements are noble gases that barely react at all, because they already have full outer shells. The periodic table is not a list. It is a map of electron behavior. Number 4. Acids and bases. An acid is a substance that donates hydrogen ions, H+, in solution. A base is a substance that accepts hydrogen ions, or donates hydroxide ions, OH-. The pH scale measures how acidic or basic a solution is. It runs from 0 to 14. pH 7 is neutral, pure water. Below 7 is acidic. Above 7 is basic or alkaline. Here is the part students get wrong. The pH scale is logarithmic. pH 5 is not twice as acidic as pH 7. It is 100 times more acidic. pH 3 is 10,000 times more acidic than pH 7. Strong acids fully dissociate in water, they release all their hydrogen ions. Hydrochloric acid, sulfuric acid, nitric acid. Weak acids only partially dissociate. Citric acid in your orange juice. Acetic acid in vinegar. Carbonic acid in fizzy drinks. Your stomach acid has a pH of about 1.5 to 3. That is strong enough to dissolve metal over time. The reason it does not dissolve your stomach is that the stomach lining secretes a thick layer of mucus and continuously replaces its cells faster than the acid can damage them. Number 5. Chemical reactions and energy. Every chemical reaction either releases energy or absorbs it. Exothermic reactions release energy, usually as heat. Combustion is exothermic. When you burn wood or fuel, the chemical bonds in the reactant store more energy than the bonds in the products. The difference is released as heat and light. Endothermic reactions absorb energy from the surroundings. Photosynthesis is endothermic. The plant absorbs light energy from the sun and uses it to build glucose from carbon dioxide and water. Activation energy is the minimum energy needed to start a reaction. Even exothermic reactions often need a push to get started. You need a spark to start a fire even though burning releases energy. Catalysts lower the activation energy of a reaction. They provide an alternative pathway that requires less energy. They are not used up in the reaction. Enzymes are biological catalysts. They do this inside living cells. Number 6. The mole concept. This is the concept that confuses students more than any other in chemistry. A mole is simply a number. Like a dozen means 12, a mole means 602 followed by 21 zeros. 6.02 times 10 to the power of 23. This number is called Avogadro's number. Why such a strange number? Because it is the number of atoms in exactly 12 grams of carbon-12. Chemists chose it so that the mass of 1 mole of any element in grams equals its relative atomic mass. 1 mole of carbon weighs 12 grams. 1 mole of oxygen weighs 16 grams. 1 mole of water weighs 18 grams. This makes calculations in chemistry consistent and practical. Instead of counting individual atoms, which is impossible, chemists count moles. The mole is just a convenient counting unit for the atomic scale. Conclusion. Chemistry is the science of why matter behaves the way it does. Every reaction, every bond, every property comes down to electrons, how many there are, how tightly they are held, and what atoms will do to achieve a full outer shell. When you understand electrons, chemistry starts to make sense. Come back for the next video. There is more to cover. Please do well to also subscribe to get more videos. Happy learning and cheers!